Welcome, everybody. Thanks for joining this afternoon. We've got a lot of content to get through, and I'm excited to have such high participation for this topic. I know we're all coming from different aspects of solar, new construction, affordable housing, and it's an area of my work that I enjoy a lot and also spend a lot of time on. We're just waiting for Emily Jones from LISC, who's going to hop on in just a second, but I'm happy to kick this off. And we'll do introductions and all that good stuff when she hops on. So yeah, thanks for joining.
Hi, Catherine. Can you hear me?
Yeah, hi, Emily.
Great. Good. Well, we're so excited to co-host this with Resonant and MACDC, and really excited to get to introduce Catherine, who's a project manager at Resonant Energy and really specializes in new construction, affordable housing, solar PV for it. So I'll turn it over to you, Catherine, to lead us through this, and then really excited to see all of the interest and happy to answer any questions and see how we can continue to engage with everyone in the room. Thanks.
Yeah, awesome. Thanks, Emily. Yeah, so just to touch a little bit about the series itself and what we're here to talk about today. So we're in partnership with LISC and MACDC to share some information and knowledge around new construction, affordable housing, how solar fits into that. Last month, we heard from our co-founder at Resonant, Isaac Baker, talk about Solar 101, financing and contracting. So today we're going to focus a little bit more on some of the more finer points and details of what that actually means for solar design, which is an area of my work that I do every day. That's my day-to-day. Next month's series will be on the nuances of zoning, certifications and all of that. So there's more to look forward to. But yeah, that's what we'll be here to do today. This is just a little bit of an agenda of what we're going to cover. We'll go over key stakeholders, who needs to be in the room, and then going through details around planning for solar on your site, what that actually means, breaking it down into certain categories of areas where we have seen good collaboration and a little bit more effort from parties as far as roof materials, racking solutions, code and equipment locations. That all comes up in the process. And then we do have time towards the end of this presentation to do a specific Q&A session. I can imagine we're all thinking of projects that we're working on or things that we've seen happen in the past. So as questions pop up, please put them in the Q&A chat or the Q&A box versus the chat so that we can compile all of those. And we'll spend the last 20 minutes of the hour just digging through and trying our best to answer as many questions as we can. We're also going to be sharing a lot of the content that you see here today out in a blog post form. We're increasing our learning and educational materials on the Resonant website, specifically around new construction affordable housing. So if there's anything here today that isn't as nuanced or anything like that, it will be in the blog post in the next couple of weeks. So with that, let's get started into some of this content and dig in here. So my colleague Isaac, last month when he did his presentation on Solar 101, touched a little bit on this, but just to recap, Resonant Energy, who are we? We're a Boston-based company working to expand the access and clean energy to underserved communities. We focus on affordable housing, small commercial. We also do nonprofits and retrofits for houses of worship as well. And when I started a couple of years ago at Resonant, a lot of my work was in the nonprofit and houses of worship space. And in the last 2 years, I've focused primarily on new construction affordable housing. So that's the who are we and who am I? So as Emily mentioned, I'm a project manager, and a lot of my day-to-day is talking to folks that we work with about their solar PV plan, how it's going to fit into their project, and all of that. So I'm excited to be here and share some of our knowledge. All right, so half the battle sometimes in any project is making sure that you have the right people in the room. So this is just a little diagram of what I mentioned earlier, what my day-to-day looks like, who needs to be in conversation when we have a solar project for new construction affordable housing. As you can see, there's a lot of people that are involved in a project at any given time. People that I speak with during the week are your general contractors, the developers, plumbing and HVAC, architects, as well as engineers and electricians. They're all involved in the project at various stages. But we'll get into a little bit about how we try to organize that communication and where we can, work together on building the solar project out for new construction. So there's that little diagram. Okay, so one question that we do get often is how and when do we engage with Resonant, or how and when do we even start incorporating solar into our project? There's a term out there called solar ready, and I think if you've been doing the work long enough, that can mean a lot of things. From a building that's solar ready might only have a conduit from the roof down to the electric room and nothing else considered. But it could also mean that more level of detail has gone into the work as well. And so we like to be in the process as early as possible. And as we go through the slide deck, you'll see what's involved and why that is. But I think the earliest that we would like to be engaged can be at a no cost feasibility analysis option. So before you're really getting started, you have 50% of your construction documents prepared. We're happy to consult and engage with any project. We find that helps get ahead of any questions or concerns or design issues early in the process. And so that's probably the earliest that you can engage with us. The second time that we would probably get involved would be around our design, what we call design phase 1. So this is after we've committed to a project. We're excited to be working together. And then it's the question of, okay, so now what do we need to do? Who needs to be in the room? And that's when we like to have more complete construction documents or CDs. That helps us identify in the actual construction drawings, are there going to be any issues or conflicts with the solar? It's a point in time where we can make recommendations of where we want equipment to go that would not only be best for the building, but also try to minimize some friction between all the different parties that are going to be on site. There's a lot of groups that end up going to build a project. And so if we can help out in any way, then we're here to do that. But what that means for us is we will consult with the developer, the GC, the architect, whoever's involved on the building set and the project to develop our solar plan set. And so the first one that we create after that consultation helps us submit interconnection with the utility. We basically do all of that and then pause. Normally for new construction, there's a long timeline. So we like to get involved maybe a year or a year and a half prior to when the building is actually going to be complete. And there's actually a benefit to that. So what that allows us to do is come in and consult early. It allows us to submit any kind of incentive programs. So we work frequently with the SMART program. If anybody's familiar with that program, it has a step down system. So as the months go on, the SMART program will step down and become less valuable over time. So the earlier we can get in there, the higher rate we can lock in for the client. So that's an advantage there. And so basically what we'll do is we'll submit our interconnection after all that consultation and just wait until design phase 2. Design phase 2 is when the building's actually there. And we have a roof that we can walk on top of, and we can do a site visit. So that's basically the next portion or the time that we would come onto site and bring our installer. We would make sure that in the process of getting from interconnection with the team to the building existing, that nothing too wild has changed on the roof. We've had instances where we do a site visit thinking the HVAC is going to be in one place and it's actually in a very different location. So things like that are why we do another site visit and then make any updates we need to our solar design set. So once that's all done, we'll submit for permits. Installation is usually the easiest part of a new construction solar project. There's a lot of work that goes in before we get to that point, but I say like every story has a good beginning, a middle, and an end. And so this is our story that we're making with new construction projects, right? So the beginning, who needs to be there, who are our characters, and getting everything set up so that we can have design phase 2 in the middle and then installation and wrap up towards the end of the project. Okay, so planning for solar equipment, what happens when we're in design phase 1? This is a slide of just an example of some content items that we will cover regardless of who's on the call. So we want to talk about things like project timeline, what's your internet plan, installation staging, any attachment plans that there are. So these are just examples of things that, maybe didn't come to mind in the architect's point of view or in the developer's point of view that would be important for us to just go over at a high level so that we make sure that we have the same strategy for the solar installation going forward. We'll get into more detail on more of these as we go. And then just to give some more information on common roof equipment obstructions. So these are things that we've seen in our work frequently that are the most restrictive to solar being installed on a project. So the way I think about it is if I see a vent pipe in the middle of a roof, that in my head means -1 panel. Same thing for HVAC, might be -4 panels. And what that really means is, say we do design phase 1 and we try to plan so that we move the vent pipes to the side of the building, or we move the HVAC to a specific spot. If by the time we're at design phase 2 and we're walking around on the roof to do a site visit and those things are in different places, that could affect the solar design overall. And basically, there's not a lot we can do at that point with the system size that we have and where the panels are going to be located. And so we would lose panels, ultimately lose panels as well as production, depending on where things change. So these are just examples of what we try to get ahead of as early as possible. Vent pipes and roof drains are 2 big items, HVAC as well. So equipment placement, walkway pads are also included. We try to have those in the middle of the building as much as possible, and gas lines. Something that we've been seeing more frequently is communications. So cell antennas, fire department communications, and then Starry Internet just has larger equipment than we had anticipated on some other projects. So just sharing the knowledge, those things sometimes go up a little bit later and are not always included in the construction design set when we're involved. So these are probably the 3 big ticket items that we like to get ahead of and try to do a lot of coordinating around to make sure that those locations don't change. And these are just 2 examples of what potential roof surfaces look like that would be difficult to install solar on. So here you can see there's a lot of obstructions here on this roof. It is a smaller roof, so keep that in mind. The smaller the roof surface is, they can provide other challenges, but we've got HVAC and vent pipes. It would be pretty difficult to put a single solar array here. We would probably have to break it up. Here's another example of, a roof that has a lot of obstructions, relatively kind of spread out throughout the roof. What we recommend is anything like vent pipes, or whatever we can, try to put that in the setback of the roof. And those are basically going to allow us to coordinate with the plumber or coordinate with whoever else so that we can have the largest array possible while still putting the pipes in areas that are good for the building. So we'll talk a little bit more about kind of what that means, but these are just 2 examples of some buildings that would provide some challenges if in the event that we thought we were going to have more space and then we have some obstructions kind of all over the place. Okay, so planning for solar equipment, it's not just about the equipment at the building that's already on site. We're going to be bringing new equipment, and so that needs coordination and space as well. One thing in particular as part of solar PV is inverters. So those can go on the roof, they can go inside, they can go basically anywhere we can coordinate them. Ideally, we need a shaded spot for them. But we've had projects where we've installed inverters on penthouse wall space on a flat roof. We've also installed inverters on the external side of a building near the electric room, and then also inside the electric room. So that's probably the most flexible part of our equipment. We can, have more conversations with clients around what works best. That is probably the most flexible part of our array that we would bring. Another important part is just making sure that there's conduit. So how do we connect our solar array to the rest of the equipment and the tie-in as well? So there's 2 strategies here. I think most common, or what we've seen in new construction, internal conduits is preferred. It allows it to be a bit more aesthetic. It's run inside the building, so you don't see the PVC running up the external side of the building. And if we're at the stage where we have 70 to 100% CDs, it's something that we can consult on. So we like to recommend a 4-inch metal conduit from the roof to as straight as possible of a line to the electric room, trying to eliminate any bends and turns there. And we do recommend 4 inches just because we've had a couple of projects where we were able to squeeze a 2-inch conduit in there, but there was other stuff running through it. So just to be safe, we go for 4 inches. And another detail about this, something that I communicate a lot, and that comes up often is, well, whose job is it anyway, right? Sometimes it's a game of hot potato, but what we try to have happen is the internal conduit at that early stage of the project is early enough to have that wrapped into the GC scope of work. So the general contractor should be able to add that as part of their building construction punch list stuff. Okay, so that's internal. And then external is a little bit easier, though not as aesthetic as some people have noted. So basically, if we're doing an external conduit, that just means that we're going to run a PVC pipe from our array to the exterior of the building down into where we're going to be tying into the electric room, whether that's internal or external. And so if that's the case, then the solar installer that we would hire would come out and do that work. And that can be done the day of install and doesn't require any coordination. And then tie-in. So often we've seen for these projects as well, affordable housing are larger buildings than often nonprofits or residential clients. They will require a separate breaker oftentimes. And so that will be something that we coordinate with the electrician on the job. Having that ready for us by the time we do site visit is important. Okay, so this is just an example of the equipment I was just talking about, just as a reference. It's not a Massachusetts example, but this is giving folks some context on how large the inverters can be. Depending on how large the system size is, we may need more than one. I'm working on a project now where we thought we were going to have a space for 2 inverters, but given the way supply chain is right now, we're actually going to need 4 different kinds of inverters. And so we're actually planning to put that in an electric room that's on the 2nd floor instead of the 1st floor. So yeah, as we plan, it's also good to be flexible. And that's why we like to get involved early so that we can have that coordination and be involved there. Okay, and I alluded to SMART earlier, but it is a program, incentive program in the state of Massachusetts that requires another meter. And so as we're talking about equipment, the things that come to mind the most are inverters, disconnects, the main meter to the building, and then also the smart meter. It's your standard size meter socket, but there are 2 ways you could place it. So what we've seen more for new construction, since it is larger buildings and often larger service, they've been either requested or had underground service drop. And so what that means is service is coming underground and into the building. And in that case, we've seen the utility require that the smart meter goes inside, which in the last year and a half has been a new development. And a lot of learning has happened around, what aspects of a project make that make sense, and how are we going to put all this equipment inside. So if that is the case and the building does have underground service, it's a really good thing that we're involved early on with the electrician so that we can designate the right amount of space per code in the electric room and fit all the equipment that we need to inside. Okay, and then exterior placement. Basically, the smart meter would go on the side of the building, on the exterior of it, close to the electric room. Metering would come out and install it, but instead of being inside, it would actually be outside. In that case, that would be similar to this setup that we have here. Just an example, this is a Resi project, but it does a really good job of just displaying what all equipment is involved and where it would go. So here you can see there's the inverter, the disconnect as well, and then this is an example of the smart meter. And it sometimes makes customers nervous to have a not have an actual meter installed in the box yet, but once the project is approved and goes through PTO, the metering department will come out and swap it, and then your solar array will be turned on and producing. So that's an example of some equipment there. Okay, roof materials and warranty. This is something that we've been doing a lot of consulting on. And so as part of this presentation and in the blog post, we're trying to just increase and share all of our learnings that we've had so far. And we found that, the trend seems to be TPO as a material for your roof has the least reflectiveness. It often hits a lot of boxes for roof types that are better for the environment or hitting other metrics for the building. And so we've seen a lot of new construction have TPO roofs, which is great. And it also provides some unique challenges for solar that Sometimes hearing TPO makes me a little nervous, just because of the requirements that there are to maintain the warranty, but also make sure that the material stays the way it should for whatever it is that it's doing for the building, whether that's insulation or cooling and management and things like that. So we just wanted to include some more information about how this could affect the solar project. TPO in particular, whoever the manufacturer is, often requires that a certified technician be the one to flash each attachment if those are needed on a roof. So attachments being just like screws and, what we would use to attach the array down into the roof. And so often we prefer to do a ballasted system, which means that we just have blocks weighing the array down. But in the event that we have a flat roof that needs attachments for whatever reason, this could pose a unique challenge. We would need to have the certified technician come out, and that can go up to $250 per penetration. So if you have a big roof or a big array and it has 500 attachments, that adds up pretty quickly. And so we do whatever we can in the early design phases to make all of our flat roof TPOs ballasted, fully ballasted without attachments. And sometimes it's not avoidable. If you have a building that's 8 stories high, it might have pretty high wind load. So in that case, we would have to have attachments. And so we just need to factor in all the design phases that would happen, the added coordination with the roofer, and making sure that we're not voiding any warranty or compromising the integrity of the roof as built. So that's just a little more context on TPO. In the event that we can choose, right, we would love to recommend white EPDM as preferred, has fewer restrictions, and we don't need to have often the certified technician from the manufacturer to come out and flash attachments. We'd be able to do that with our installer. So if we had a choice, that's what we would offer. Okay, so this is an example of a building. This is actually a project that we're working on called 137 Amory. And I just wanted to show kind of how a design can change from design phase 1 to design phase 2. So if we remember, design phase 1 is, we have our 70 to 100% construction drawings. We're basically using that to inform our design. And if you can see, it looks like we have a lot of space here. We're able to keep our array pretty much connected. And so that's important for a solar array, just because the more you separate pieces or separate the panels themselves into different sections, the heavier each grouping can get and the more likely it is to require attachments, which is what we're trying to avoid. So what happened here is we had our 100% CDs. We applied for interconnection, and so we thought we were going to have more space. And we ended up doing the site visit and found that there are actually more vent pipes in places that we did not want them to be in. Ideally, we would have put these vent pipes in the setback, but that's kind of an explanation of what happened here. And so what ended up being the case is we were able to actually move the project forward, which is great. But you can see that there is some sectioning of different solar arrays. We try to say something other than islanding, because islanding is another thing in the utility world, but you can see here that there's an array that's islanded, array 1, array 2, array 3, and array 4. And so these would be a little bit heavier than just keeping the array all together, fully ballasted that way. But yeah, this is just an example of something that, even with all the coordination and working with teams, that can still lead to some surprises at the site visit. And we're more than happy to work through all of them. And that's why we like to be involved early. And so this is another example, but of the opposite thing. So this is an example of a project that we completed with Madison Park Development Corporation. And as you can see here, instead of having any kind of sections or islanding, we were able to keep this array pretty much uniform and all over the roof, which allowed it to be fully ballasted and didn't require any attachments, which is great. And provides for an easier installation, in some cases, a larger solar array and more production. So, we have the success story of this is what the ideal flat roof, surface would look like, and then working through whatever challenges pop up throughout conversation. Okay, so talking a little bit about roof materials. Also moving on to roof warranty process, because that is an important part of, making sure that the solar doesn't void any warranty that currently exists. They happen relatively similar timing. So when the roofer goes out and is wrapping up the roof and wrapping up the warranty process is around the time that we're going to be doing our site visit for the building. And so it's a good time and moment for us to meet with the roofer, just to get on the same page with whatever it is that they're requiring. We want to make sure that it doesn't impact any existing warranties. There's been so much work and effort going into a new construction project that once you get to the end, you want to make sure that you've dotted your I's and crossed your T's. So sometimes this might require paying the roofer to do a pre and post inspection just to make sure that the warranty isn't voided, in which case all of those inspection costs are covered as part of the solar project. And it's something that we coordinate in advance. Many warranty providers have a specific language or pamphlet around solar and what it means to install the solar on their roof. So that's something that we coordinate in ahead of time. All right, structural and racking solutions. So this is just an aspect of the project that we like to plan. So the structural planning is very important. We want to make sure that when we have our design phase one all the way to the time that we're standing on top of the roof, that we have done everything we need to make sure that we have enough support for the array. So for flat roofs, what we see is 10 pounds per square foot of dead load capacity is normally what we recommend to be allocated for solar PV. If you're doing a solar array that is a bit more dense or wavelet, we'll go higher than that and request 15 pounds per square foot. These conversations normally happen in design phase one early, where we'll take a look at the structural set, make sure that everything's going to work out. We often work with racking manufacturers for solar racking in advance and get what they call a ballasted map for flat roofs, just to take a look at the structural and ahead of time and make sure that we're lining up expectations. For slope roofs, it's a little bit easier. 5 pounds a square foot dead load capacities should be allocated. And for slope roofs, they're just can be an easier installation because you're just using the attachments onto the roof and not as much structural is really taking place. Okay, so this is just a chart example. Again, it will be up on our blog post as a reference point. So as we're going through with new projects or we want to share some resources, we wanted this to be as much of a learning tool as a presentation also. So you can see here something it's what I mentioned earlier, but ballasted mounted for flat roofs, what we see is 6 to 9 pounds per square foot, and what we recommend is 10 pounds per square foot. And then mechanical attachments for slope roofs, we recommend 5 pounds per square foot. And if there are going to be attachments for a ballasted system on a flat roof, then we would recommend 7 to 10 pounds per square foot. And then this is an example of the densest racking type that a solar array can have. We're currently doing this on a project now with the City of Boston's E+ initiative. So basically it's the heaviest solution, but it allows for the highest level of energy density. And so that's just one example of a way you can think creatively about fitting more panels onto your roof and more energy out of the system as well. I'm recommending 15 pounds per square foot. Okay, great. And then code requirements and equipment locations. So I mentioned earlier, as I was going through some of the photos, having vent pipes in the setback, having the solar array in a certain position so that we're a certain distance away from the roof. What we recommend for flat roofs is 4 feet from the edge of the roof as the setback. So that's the area around the solar array that folks can walk around or do maintenance and things like that. And then for buildings that are greater than 250 feet, it's often required to have a fire lane somewhere in the middle there, just for safety and requirements. And then what we see on slope roofs, it can depend on the building, but we'll usually see a 3-foot path from the eave to the ridge and 3-foot path along the ridge as well. And then for slope roofs, another detail that's important to include is snow guards. So these are little pieces of material that we put on the end of our solar array that is normally above walkways or entryways that would be able to catch the snow and redirect. So that's another element there. Something that's important to note, which is why I started, is that setback requirements definitely vary by township. We've had a couple of projects have varying degrees of setbacks. And so it's really important in collaborating with your local inspector when we're building a project that's something that Resonant will take on, and the design one phase where we'll have our design that we're going to submit for interconnection. We'll also work with the township if there's any doubt or questions, just to make sure that we have enough space there. But, you know, in terms of setback goes, the biggest thing that we recommend is definitely 4 feet. And if there are any vent pipes or obstructions, either keeping them in the middle of the flat roof space as much as possible so that we have as much surface area for solar, or if that's not possible, then trying to put those in the 4-foot setbacks, because that's still allowed by code. So those are our 2 recommendations towards setbacks there. And then the last thing in terms of detailing, you know, as we're building the project, there will be different levels of fall protection. So during construction for flat roofs, often there's weighted rails. For slope roofs, there's temporary anchors, and those will be moved around as the building is being constructed. But then in terms of fall protection for ongoing management, we've seen a couple of varying things. So parapet walls, if they're greater than 39 inches in height, those are fine to have as a fall protection method. And then what we have seen and what we'd recommend is for ongoing operations and maintenance, having tiebacks in the setback of the solar array area. So if we have a 4-foot setback and we're going to do tiebacks as an option for fall protection, just having a couple of them across the building in the setback zone so that they're not in the space of the solar array, but still meeting that fall protection requirement. Permanent rail is also something that we've seen as well. And then we've also seen a 10-foot setback from the roof edge, but that's been very uncommon and can reduce the amount of solar that we can fit on the roof as well. And so where possible, we recommend and prefer tiebacks in the setback zone. Okay, so I haven't taken a look at our Q&A session at the moment, but that concludes the content of the presentation. It's a lot of information, and I'm excited to reshare some of it in blog form or resource as well so that folks can refer to it. But just to recap, this is work that we've been building for a couple of years now, and because of what solar ready can mean in a varying like degrees of the definition, we're really interested in working with our partners and with developers and architects and all the folks involved in these projects so that we can have some form of collective knowledge sharing to maximize the solar array, make it the most productive and possible for whatever affordable housing project and initiative is going up as well. We have a couple of design phases that we do. We're happy to consult early on. And then we'll have 2 design phases of the process and plan all of our equipment locations, the building's equipment locations, and whatever requirements or setbacks or anything else is needed for the project. So I'm going to pause here and check in with our Q&A, and then we'll have some dedicated time to start answering some questions. Okay, great. So I'm going to start answering some of these, and thanks to everybody who was listening and then also put questions in the chat. If you put a question in the chat, if you don't mind just putting it in the Q&A as well, and we'll do our best to get through some of these. So let's see. All right, the first one here, why wait until 50% construction documents? Seems late in the process. Thanks for that question. We find that 50% CDs, as far as solar is concerned, actually feels early to us, just because certain things can change throughout the project that would affect where our array would go, where we would put, the inverters, or where we would have our tie-in in the electric room. We've had more success consulting for for interconnection plan sets and actually doing designs closer to 70 to 100%. But for things like questions about, where should, how much space in the electric room do I need in general for new construction project and solar, 50% CDs is more than enough to be able to answer a question like that. And as I'm going, I'll take a minute and just pause, because I think my colleague Isaac might be on the call, but I don't know if he can speak. So if there are any questions here that I can't answer, we will definitely send out a follow-up after this call with some more answers as well.
Catherine, can you hear me?
Yeah, hello.
Hello, hello.
Great. yeah, I figure we could just take a stab at these. If you have anything that you want to add, Isaac, as we go, feel free. Okay, great. And then another one, when you're talking about ballasted installations, this adds significantly to the roof loads, needs to be determined early, and not just ballasted installs. Yeah, so that does need to be determined pretty early, which is why we like to get involved with the structural team at that point, or whoever is going to be doing that set. We don't want that to be a question by the time that we're submitting for interconnection or submitting for our permit set either. So that's something that we definitely coordinate closely with. And we also, like I think I mentioned this in the presentation, we'll work with the racking manufacturer to get what's called a ballast map. And so that's whether they run some of their structural calculations just to make sure that we have enough load for our solar array. And we've also been telling folks, it is a lot of weight. And so we are asking for, if it's fully ballasted, 10 pounds per square foot. If it's going to be denser than that, 15 pounds per square foot, trying to start those conversations early on in the process so it's not a surprise to anyone. Okay, Isaac, I see you're typing an answer.
Well, I don't know if it's easier to do that, but I'll just take one here. So there's one question about, is there a document in MA that outlines the solar setback requirements? And if so, what is it? So this is just the building code that outlines setback requirements for solar. Solar is treated alongside other rooftop equipment that can be added specifically to a flat roof. And so many architects are familiar with that kind of 10 or 15-foot style setback from the roof edge, which is often what people optimize for and why you see a lot of HVAC centered along the spine of a roof. However, solar and other equipment is allowed up to a 4-foot setback from a flat roof's edge, as long as you have some fall protection measure in place, whether that be the parapet wall, the railing, or the davits. So if there's feel free to follow up with us by email if you want an even more specific reference in the building code to exactly where it is, but that is where that one lives.
Great. Yeah, thanks, Isaac and Carrie, for your questions. Okay, the next question we have, at what point do you interact with the basic design of the building, like orientation and roof slope? And do you ever use microinverters? So to answer the first one, as early as the site plans are shared with us, again, we can do consulting as early as 50% CDs. And in terms of interacting with it, what that actually takes shape or looks like is we'll have an email back and forth with whoever's asking the questions or wanting us to take a look. And then often we'll have a first, once we've committed to a project, and we have some documentation from, the developer and the, design team, we'll have a big call with everybody involved and kind of go over all the details of the building there. And do we ever use microinverters? We do, and it does depend project by project, whether it's, if we're dealing with sometimes if there's a lot of obstructions, it could cause some shading. So we might want to think about microinverters there. I think we're all, if you're familiar with the solar industry at the moment, inverters in general have been pretty hard to come by. So a lot of us have been thinking creatively about how we can get the right inverters for the project type. But that's just an aside.
And I'll add just on microinverters that we mostly don't spec them for multifamily out of the gate because they are more expensive for larger commercial projects, where you see them on residential systems very commonly. And in small commercial applications, you'll more often see a central inverter with optimizers as the way to address that, because the Enphase, which is the most common manufacturer of microinverters, it comes at a cost premium, both in terms of the labor to install and the actual equipment cost itself. But to Catherine's point, we're getting creative right now due to supply chain issues, and especially on small commercial, if it's like a 15 kilowatt, almost residential size system on a multifamily building, then you might see it at the small end of the multifamily segment.
Yeah, thanks, Isaac. And that covered, I think, Christopher's question as well. Are microinverters typically not used for multifamily? So great. Looks like another question here from Zoe. So how do the owners you work with typically finance their solar installation, PPAs, debt financing? So I'm happy to take a stab at this, and Isaac also, because I know that that was part of what we covered in our last session was, how do we finance these projects? Yeah, so the short answer is yes, we can do a direct purchase if the financing is available and the client is ready to move forward. But we also work with other financiers like Sunwealth, namely Sunrun as well, to offer PPA contracts and third-party financing for their project. As far as debt financing goes, the client, we've worked with other clients that get their own loans or work with their own resources to finance the project. But it is part of something that we work on with the client to make sure that they can afford the project that they're moving forward with.
And that covers it all very well. And the only thing I'll add is when it comes to debt financing, most developers we work with do not take out an additional loan specific to solar. So if you're going to buy the solar system, you're going to wrap it into the total development cost for the building itself. And the main difference between solar as a line item than anything else you might put in your building is that solar has these revenue streams. It has a cash payment revenue stream from the SMART program, and it lowers the operating costs, both of which can and should be factored into a debt service coverage calculation to basically create space in your budget and allow you to borrow more from your existing senior lender and other lenders on the project, so that solar is not just a drag or an extra cost, but is actually the revenues associated with it are being factored into your debt service calculations and other items. Because that is complex and requires planning upfront before developers close on financing, we often then need to go with a no-cost option, as Catherine noted, because there's not room in the budget. And lastly, what I'll say is we've had a few developers who said, we think we have room in the budget, but we're not totally sure. And we might run out of room in the budget if things go sideways during construction. And we have signed agreements with those folks, which is our first creative iteration where we sign a direct purchase contract that gives developers an out that says up until a certain milestone, you have the option to get a refund on your payments so far and switch to a no-cost financing option. So we are working really hard to be creative with folks because we know that the costs associated with solar has been the single biggest barrier to date for whether solar is being adopted in the multifamily segment.
Yeah, great. Thanks, Isaac. Next question we have from Elizabeth. So can you explain the difference in terminology between islanding and section for the utilities? Yeah, I'm happy to go back on that because I think I didn't quite explain it as well as I could have, but it's islanding is something in the utility is when the distributed generator is continuing to deliver service to an area that's no longer present or tied into the electrical grid. As far as I understand it, I'm not like the expert on the topic, but it is, I've been calling, different sections of solar panels on roofs islands. And that can cause concern when I say the word islanding as it relates to PV and, general service. So basically, instead of islands, I've been calling them sections, but that really just means the different arrays that are located on the roofs. And if you recall to the example I showed you of our project at 137 Amory, really we're just referring to those as sections, as individual groupings of panels on a roof that we would have liked to have all kind of just in one big array. So thanks for asking that clarification. Okay, great. So from Michael, what are the implications for solar installations on existing buildings and roofs? In particular, what's the impact on a roof that has several years expected lifetime? That's a good question. In part of our analysis, when we're taking a look at a building, one important factor is that we want to know how old the roof actually is. So for a retrofit project, that's something that we'll take a look at. But for the most part, we do the project from start to finish. What I was talking about in terms of roof warranty will remain the same. So we'll take a look at the existing roof warranty for the building, make sure it has a good life expectancy, and that we're not voiding it when we're up there. As far as operations and management, there's very little that needs to happen for a solar array for a retrofit project. And if there's any issues, then we have operations and management help figure anything out and troubleshoot. Okay, so there's a question from Zach here. Isaac, I'm happy to have maybe your thoughts on this one. So nonprofits and housing authorities cannot benefit from the federal tax credit. So are these actually good prospects? And I think maybe if you want to expand on, how this makes sense for projects in terms of an incentive standpoint.
Yeah, it's a great question. And the short answer is yes. So many nonprofits who build multifamily housing are going to partner with a tax equity partner to finance the low-income housing tax credit. And so even though they are a nonprofit, there is a for-profit partner who's a part of the development who can use tax benefits. So if you have a low-income housing tax credit or a historic tax credit deal, technically possible also with a new market tax credit, but with a little bit more complexity. Any type of those tax credit deals, you can kind of bundle the solar tax credit in and sell it. So even if you have a nonprofit developer, you have a means of selling your tax credit. If a nonprofit is developing a deal without tax credits, which some do, especially if you're in the sort of like middle income or workforce housing segment, we see a lot of nonprofits developing non-tax credit deals. In those cases, you have two choices. We either have hybrid ownership options where we can monetize the tax credit and help them finance their solar array, but still finance the rest with debt and basically just get them a discount by selling off the tax credit. Or they more commonly, nonprofits and housing authorities will just go with that no-cost power purchase agreement option and have a third party use the solar tax credit that way. So again, lots of creativity, still great prospects, and any project in almost any project in Massachusetts of a reasonable size, we can find a pathway for financially. But there are more limitations if you don't have an immediate way to monetize that tax credit. So we got to get creative.
Cool. Yeah, thanks, Isaac. Okay, next question here. What are the biggest challenges to the use of solar panels after installation? Does Resonant Energy follow up with owners after install to monitor the solar performance? So that's also a good question. It kind of touches to what I alluded to earlier. There's not a whole lot of O&M that needs to happen once we install a solar array. I think some of the biggest challenges that happen post-installation actually have to do with weather. Especially being in Boston and the Northeast, as you can imagine, things like snow and wind, storms and ice. Those are probably the most common issues that we see where, it might cause the solar array to either not produce as much as we thought based on weather patterns. When it snows, the snows often can cover the panels, and sometimes we'll get a call from a client asking, hey, like why isn't my system producing? But it's just because it's covered in snow. And, do we follow up with our owners after the installation or monitor the solar performance? Yes. So we have partnered with a third-party O&M group called Omnidian, and we, towards the end of the project, will onboard our clients as an option, we'll onboard our clients with this group, and they basically monitor the solar performance. If there's ever any issue, they will open a ticket for it, send somebody out to take a look, keep everybody that needs to be in the loop. Sometimes these buildings, depending on what kind it is, might have a property manager or just an individual. So we make sure that that's all set up before we close out the project. And then, we're always a point of contact even after the project is built. We'll definitely help direct whoever needs help into the right place. And so we're not installing the system and then just leaving the client high and dry on that, because it is an important part of making sure that the system is producing for the long term and is, performing as it should.
I can hop in with the next one from Franklin Miller, which is, do you gauge how many panels to install based on energy need for the building or how much space is available? We covered this a little bit in the previous presentation. So the first one is in terms of space available. Yes, we look at building drawings and see how many panels can fit on the roof. And then the second question is, obviously, we don't want to provide more power than the building needs. So as part of our assessment, we take a look at what types of loads are connected to the house panel, and we put together a projection of what the estimated electricity usage will be. In most multifamily buildings, we're tying the solar PV behind the meter of the house meter. So then we need to project what's the usage of the house meter going to be? You got laundry, elevators, parking lot lights, etc. We come up with a model for that, and we say, you're going to use 80,000 kilowatt hours per year based on our initial estimate. We're going to produce 50, so we're offsetting 2/3 or something like that. So that all comes as part of our initial analysis. And I will address just quickly Michael Schaaf's second question here on Ipswich site plan review, and that installers have been charging $300 for a feasibility analysis. Does that seem reasonable for folks to charge that fee? The short answer is yes. It takes a few hours worth of work to do that analysis. And when you bring in a solar consultant so early in the process for site plan review that you haven't committed to working with them. And so it's pretty reasonable to offer that. Resonant is very confident in our abilities and the idea that most of our clients that we provide analysis to choose to work with us. And that's why we offer it that type of analysis for free. If we were to find that we were putting out a lot of analysis and people were not then working for us, we would need to start instituting a charge. So $300 seems fairly reasonable for that preliminary assessment, especially for installers who are worried that they may not get the business later in the process.
Great, thanks. And Noah's question, which is the last one that we have here, is similar to Franklin's question that you already answered, Isaac. So I guess we have a couple of minutes left. If there's maybe one more question that was burning on somebody's mind, feel free to put it in the Q&A. Thanks to everybody that joined for the hour of the presentation. Again, we've recorded the session, so we will share it out with everybody after this. We're also working on our blog post that has pretty much everything that I spoke about today in a different format, so it can be referenced. Or if you're working on a project or have questions, you can refer to that. And then we'll look forward to our next session on zoning and the nuances of that in August. And I think I'm happy to let people off.
Catherine, we do have one more question that came in the general chat,
Okay.
Which was, if a company doesn't have the resources for a rooftop system or does not have the space for a rooftop solar system, what about community solar and participating in an off-site array? The short answer is that Resonant, we're a small commercial solar developer, so we develop some community solar projects, but most of the systems that we develop and work on directly meet the needs of the building that the panels are placed on. We have a handful of sites where we find clients who have parking lots or larger spaces where they can produce more power than they need and occasionally develop community solar. So those opportunities are available, and there are many developers, including Blue Wave, Nexamp, and a handful of others in the state that have operating assets all across, the kind of 5 megawatts out in a green field. So one can do research on that. And what I will say for affordable housing is that it can be a little bit complicated for them legally to participate because there's so many different legal entities. Every building has its own LLC. And that can just add to the amount of brain damage and legal paperwork involved in getting your affordable housing development signed up. But housing authorities are some of the most common participants in offsite community solar because their legal ownership is much simpler and they're a publicly rated credit. So they're good to do business with for the long term. So there's been a lot of housing authority adoption over the last 5 years of community solar. And that's something we can advise on as an organization in a consulting capacity if folks have interest in pursuing that, but is not generally our core focus. And our main goal is to help people get panels up and make use of our available rooftop.
Yeah, great. Awesome. Thanks for that summary, Isaac. In the event of that, I think that brings us to the end of our questions. We'll type up some answers of what we just talked about for the folks who had the questions and send that out as part of our follow-up. Looking forward to the next session in August, and thanks again to our partners, Emily at LISC for organizing some of this with us. So yeah, hope everybody has a great rest of your afternoon, and we'll be following up with all of the other resources that we have.